Okay, here we go, linear graphs, flipped lesson number 2. So last class, we graphed equations that were in slope-intercept form, like number 1. We graphed this one by first noticing that the y-intercept was 1, and the slope was -4. That meant down 4, 1, 2, 3, 4 over 1. And we connected those two dots the best that we could. Miss Overby, you need to use a ruler. And then we saw things like this, where we had y-intercept was -5, 1, 2, 3, 4, 5. And we learned that having a slope that was a fraction was actually a good thing, because in number 1, I had to change the slope, right, to -4 over 1 to remember to run 1. When you have a slope that's a fraction, you simply just go up 3, 1, 2, 3 over 1, 2, 3, 4. So I'm going pretty quickly because we spent some time last class working on these. And now we're going to look at number 3. We still did these in class last time, but we need to officially make sure we take some notes on this. So this looks different, right? If we were to write y equals mx plus b over it, we see that our slope is 2, but then when we go for the b, it's like, where is it? It's missing. When something's missing, you don't have any of it. We don't have a y-intercept. It's missing. Therefore, all right, we do have a y-intercept. It's missing because it's 0. So I could either write it as y equals 2x plus 0 or y equals 2x. If I write it as plus 0, it makes sense why the y-intercept is 0. If I don't write it, I just have to remember it's not there because it's 0. And then the slope is 2, and that means rise is 2, run is 1, so up 2 over 1. Connect the dots, try to make both dots. Yay. I'm going to encourage you to use rulers when you are connecting dots so that they look correct. In last class, we also worked on when the slope was missing. So if we had this and we put y equals mx plus b, we're like, wait, y equals, okay, my mx is missing and my b is this. Okay, so that would be an easy one to start, right? My b is -2, so I go down -2. And my slope is missing, so we can approach it 2 different ways. We could either rewrite this, and we looked at this in class, we could rewrite this as y equals 0x minus 2, right? Instead of writing y equals -2 like we see that, the x is missing here because there isn't an x. If there's no x, we don't write it. Or we could always just write 0x because it means the same thing, that there are no x's. But when we write it like that, then it's easier to see that it's in mx plus b form, right? We can see that the slope is 0. We can see that the y-intercept is -2. So if the slope is 0, that means there's no rise. There's no rise. There's a ton of run, but there's no rise. So I'm going to go ahead and put a flat line through here, through the y-intercept. And this represents no slope, right? If I were a person walking on this line, I wouldn't say, oh, this is such tough work. I'm walking on this steep line. No, it's a flat line. There's no slope. That's one way to do this. And the other way to do it is to explore this by looking at a table. If I go back to my original equation that says y equals -2, well, then when I set up an xy table, I could go ahead and set up my 3 x numbers, right? -1, 0, and 1. But when I go to plug them in, there's no x to plug in. And all this equation just keeps saying is y equals -2, y equals -2. Well, when x is -1 and I go to plug it in, all I get is, hey, y equals -2. Okay. If I plug in 0, there's no x to plug it in, right? And the equation just keeps saying back to me, y equals -2. Okay. If I plug 1 in, you get the point. No matter what the x is, I could keep going. I could keep going to 1,000,000, right? Y is always going to equal -2. So think about the line that we just drew. Every single point on this line, like this point is 1, -2. This point is 1, 2, 3, 4, -2. Whoops, -2. This point is -2, -2. This point is 1, 2, 3, 4, 5, 6, 7. -7 comma -2. You get it? Every point on this line is going to have y equal to -2. And that's why this line's name is y equals -2. I don't care which method you do. Just use the one that makes sense to you, because our brains will remember whatever makes sense to us. And last class, we also talked about what to do when the y is totally missing. Well, we can't change this to y equals mx plus b, right? Because there's no y. So we're going to use a table to explore. We're going to go ahead and say, well, let's see. Can I put my -1, 0, 1 in for x? Oh, no, I can't, because x is equal to 4. That means my table is always going to have 4 for x. My y can be anything it wants to be. It could be 0 or 1 or 2 or -1 or -2. So when I graph this, look what's going to happen. When I graph this point, that's 4, 0, so that's going to be 1, 2, 3, 4. When I graph this, it's 4, 1. When I graph this, 4, 2. When I graph that, it's 4, -1. And when I graph that, it's 4, -2. When we put it together, we can see that it is a vertical line. Right? And every point on this line has an x that's equal to 4. That's why the name of this line is x equals 4. And so there's a real goofy way. Sometimes we need some goofy ways to remember things, because there's so many things that we need to actually memorize in math so that we can do the harder things that involve more thought. And so sometimes it helps come up with little tricks. So one of the tricks here is that I remember that, let's say, maybe your mom or your dad or your grandma, whoever you live with, doesn't say this when they look at your room. They don't put their arms way out and go, "Why is your room such a mess? Is your room such a mess?" I don't know. Maybe your room isn't a mess, and maybe your guardian isn't demonstrative and throw their arms out in the air. But that's how I remember that when I see y equals 4, I'm going to graph it by I'm going to find 4 on the y-axis, and then I'm going to have a horizontal line, just like the horizontal line that my parent or guardian would make with their arms. Why is your room a mess? Why do you have a walk-on closet? Like when your clothes are all over the floor. And so if y always looks flat, like a horizontal line, then x has to be the opposite. X equals 2 is going to be a straight vertical line up and down. So if that helped you, great. If not, you figure out in your mind a shortcut to understanding why y equals 4 is going to be a horizontal line with a slope of 0. And x equals 2 is going to be a vertical line with the slope actually that's undefined. So if we didn't talk about that in class, the slope is undefined. Okay, so we just spent the first, let's see, how long are we into? The first 8 minutes reviewing some important things that we discovered in class last time. And so now let's go to the new. Here's the new. What happens when the y is not by itself? And right here, look at this. Oh my gosh, we're used to the y being by itself, right? We're used to like y equals 3x minus 5. No, there's this 4 here. What are we going to do? Well, let's get rid of it. Let's get y by itself. And so we're going to remember some of the rules that we learned last year in pre-algebra in middle school, where we looked at the 4 and it says plus 4. Well, to get rid of it, we're going to have to do the opposite, right? To get rid of a 4, we're going to subtract a 4, because 4 minus 4 is 0. Voila, it's gone. Okay, so it's gone. We're going to bring the y down. What you say? I can hear you saying it, even though I'm behind the screen. All right, you're saying, wait a minute, Miss Overby. If this is an equation where both sides are equal to each other, and you just subtracted 4 from one side, now it's not equal. You've got to subtract 4 from the other. Oh, thank you. Thank you for reminding me. I'm going to subtract 4 from the other. Now, I'm not going to subtract 4 from the 5x, because 5x and 4 are not like terms, so they can't do any addition or subtraction together. So I'm going to bring down the 5x, but am going to combine the negative 2 minus 4. So in my calculator, I'd hit negative 2, then minus a 4. I hit enter, and I'm going to get a negative 6. So look what we have now. We have got a line. We've got an equation that's in slope-intercept form. Yay! So that's what we're going to do, class. Each time we see an equation where the y is not alone, we're going to work until the y is alone, and it's in the slope-intercept form. And now we know how to graph, right? That's my y-intercept. So I'm going to find 1, 2, 3, 4, 5, 6. And that's my slope, which I'm going to remind myself to run 1. So to find the next point, I'm going to rise up 5, 1, 2, 3, 4, 5, and run 1. And there we have it. So that is the first new part of our lesson. Let's see if we have something else new. We do! All right. So this is the same thing, right? Oh, it is a little different. I agree. There are parentheses here where the last one, we didn't have parentheses, did we? All right. So we do have to get rid of the negative 3. I agree. It needs to go to the other side. But we have parentheses to deal with first. So before we even work with this, I want you to stop for a second and read this. I actually just scooted out of the way in front of the screen as if you're still sitting here in the class and looking at. Okay, you can see it. I didn't need to scoot. All right, so this is called point slope form. And this is an important form, but we are not going to graph from this form. We are going to change it into slope intercept form. So before we can move the 3 over, the negative 3 over, we're going to get rid of these parentheses so then it can look like the problem that we just did. So here we go. When we have parentheses, it's telling us that the 2 needs to be distributed to both things in the parentheses. Is this coming back to you? So we're going to go ahead and say 2 times x. Well, that's just 2x. 2 times negative 5 is negative 10. Then we're going to bring down the y minus 3. So when we see an equation that's not in slope-intercept form and has parentheses, we want to distribute to get rid of the parentheses because now the problem looks just like the problem we just graphed in problem number 6. So here we go. We want to get rid of that negative 3. And how are we going to do that? That's right. To get rid of a negative 3, we're going to add a 3 because negative 3 plus 3 is 0. So it's gone. We got a y. That's right. Whatever we do to one side, we have to do the other. I'm going to add a 3, and I'm just going to combine the negative 10 with the 3 because the 2x and the 3 are not like terms, and we cannot add or subtract like terms. They just don't add or subtract with each other. So we're going to bring down the 2x, and negative 10 plus 3 is negative 7. So now we're going to graph this. We know that our y-intercept is negative 7. 1, 2, 3, 4, 5, 6, 7. And we know our slope is 2. That means rise up 2, run 1, and there you have it. So the new part of this lesson was pretty short. I went through it pretty quickly. So since this is such a short lesson, you may want to go back and listen to me teach number 6 and 7 again. But we're going to practice these a lot in class. So thank you very much for joining me. You guys are doing great with these flip lessons, and I look forward to seeing you in class.